Welcome back to AIM Chemistry, Learn Chemistry with Dr. Poonam. This calculation of strong bases by method 1, where we use two simple formulas. pOH is equal to negative logarithm to the base 10 hydroxyl ion concentration, and then later pH plus pOH is equal to 14. By using this formula, we have calculated pH and H plus concentration of strong bases. I already told you there is again one more method, that is method 2. So method 2 is about calculation of pH of strong bases, but here student we need to use ionic product of water. In calculation we have to use this new term, that is ionic product of water. So before actual calculation, here in brief we will discuss the concept of ionic product. As student, we know that water undergoes self-ionization and it is a weak electrolyte. So it can easily split into its ion. Auto-ionization means it will split into or separate into its ions. So it will be H plus OH minus ion. It is in aqueous form and it is also in aqueous form. So for this equation we need to find out equilibrium constant. When we apply law of mass action at equilibrium, so the equilibrium constant, that is a product of product divided by product of reactant, so it will be H plus, concentration of H plus into concentration of OH minus ion divided by concentration of H2O. This is the equilibrium constant for auto-ionization of water. After applying law of mass action, we get equilibrium constant equation. But student, as we know that we are just dealing with water. As dissociation is small, the water concentration is very large compared with dissociated ion. So the changes to its volume or value of this water is insignificant. And this is the reason, student, we take concentration of water as a constant. So here we use a new term, and that new term is Kw. So that Kw means ionic product of water. So here there is a insignificant to take concentration of water because it's a constant. So instead of taking this, only we take product of H plus ion and OH minus ion. And the term Kc, equilibrium constant, when it comes to water, it is replaced with the word Kw, and the meaning of Kw is ionic product. Ionic product, that is Kw. So from this equation also we can very easily define what is meant by ionic product of water. So here we can see that this is the product of concentration of H plus and OH minus ion in water, and at particular temperature, student. The ionic product value is temperature. It depends on temperature. With the temperature increase in the temperature, value of ionic product also increases. So here we will take a value for 25 degree Celsius. So when we take maybe you understood, otherwise you can note down this definition. The product of concentration of H plus and OH minus ion in water at particular temperature is known as ionic product of water. As I already told, student, you can pause video and just note down this definition. The value of ionic product increases with increase in temperature, but generally we take a value at 25 degrees Celsius or 298 Kelvin. So at 25 degrees Celsius, or we can say 298 Kelvin, Kw is equal to same concentration of H plus into concentration of OH minus ion, and its value is, because it's H plus is 10 to the power minus 7 and OH minus is 10 to the power minus 7, so it will be 1 into 10 to the power minus 14, and its unit is moles square cubic decimeter to the power 6. So student, this is the value of ionic product at 25 degrees Celsius. In maximum cases, in maximum problems, you will find this value is given in numerical, and if it is not given, that time you have to consider that the value of ionic product is at 25 degrees Celsius and it is equal to 1 into 10 to the power minus 14. Now we will solve some problems regarding this. So student, we can note down this problem. Calculate the pH of solution of sodium hydroxide with concentration is 0.05 mole per cubic decimeter. And see students, here ionic product value is given and temperature is also given 298 Kelvin. That means its value is at 25 degrees Celsius. So to write its solution, to find out, we need to find out pH. But what is given? The concentration of sodium hydroxide. So sodium hydroxide, the square bracket means concentration. So concentration of sodium hydroxide is 0.05 mole per cubic decimeter. So student, here in previous class also I told you, whenever there is a sodium hydroxide, because we are dealing with strong base and sodium hydroxide is strong base, so strong base dissociate completely. So this is the reason concentration of base whatever given is equal to concentration of hydroxyl ion. So what is the concentration of sodium hydroxide given? It is 0.05 mole per dm3. So it means that student, concentration of hydroxyl ion is equal to concentration of sodium hydroxide because it is strong base and it is equal to 0.05 mole per dm3. Now just we need to find out pH, that means we need H plus value. So our second, this is our step 1. So in step 2 students, write equation Kw is equal to, that is ionic product of water, is equal to H plus OH minus ion. And just because we have value of hydroxyl ion and Kw, we do not have value of H plus, just rearrange this equation to concentration of H plus is equal to ionic product divided by concentration of hydroxyl ion. Values are already given. Value of ionic product is 1 into 10 to the power minus 14 divided by hydroxyl ion concentration is 0.05. So your calculators are ready maybe. So students, you can calculate this value. So directly do 1 divided by 0.05 into 10 to the power minus 14. Then we can arrange to significant figures. So it will be students, my answer is 2 into 10 to the power minus 13 and its unit is mole per dm cube because we are calculating concentration. Now next, calculate directly pH. Your step 3rd will be calculate pH. pH is equal to negative log 10 concentration of H plus. Now from this equation you already calculated concentration of H plus. So put this value 2 into 10 to the power minus 13, you will get your pH. Calculate students. My value is 10.7. You can recheck. Pause this video and note down steps. Again one more problem we will discuss. Calculate the pH of 0.015 mole dm cube of sodium hydroxide, where again ionic product is given student. So simply again by step 1, find the concentration of hydroxyl ion. So that means concentration of sodium hydroxide is equal to concentration of hydroxyl ion and it is equal to 0.15 mole per cubic decimeter. Now in step 2, write down equation, ionic product equation, concentration of H plus into concentration of OH minus. Just rearrange this equation to, because we have to focus on concentration of pH, so we should know H plus ionic product divided by concentration of OH minus ion. So put this value, Kw is equal to 1 into 10 to the power minus 14. Hydroxyl ion concentration you have already 0.15. From this you will get your value, students. So this is equal to 6.66. Directly in calculator you will get this value. Unit is mole per dm cube. After getting H plus, just your step 3 is to calculate pH. So how to calculate pH? pH is equal to negative log. If you want to write 10, base 10, right? Otherwise the meaning of log is to the base 10. And H plus, so is equal to negative log 6.66 into 10 to the power minus 14. Calculate, students, and note down value. It is equal to 13.17. So in this way, students, we have calculated pH of sodium hydroxide solution, where we are focusing on strong bases, student. Please, because when it comes to weak acids, then your formula will be different. So note down formulas. When you have strong acid, your formula will be directly concentration of H plus is equal to concentration of given acid. So your formula is directly pH is equal to negative log to the base 10 H plus. Now if you have strong base, we use the two different formulas, method 1 and method 2. Method 1, method 2. In method 1, you need to use the formula POH is equal to negative log to the base 10 or hydroxyl ion concentration, and pH plus POH is equal to 14. So from this equation you will find hydroxyl ion concentration in problem, and then you can calculate this accordingly. In method 2 you need to use ionic product of water, if ionic product of water is given. So here if you want to calculate H plus, just need to rearrange this equation, is equal to ionic product of, and even student directly you can calculate H plus concentration or hydroxyl concentration also, whatever given and what you need to be calculated. So in this way, students, you can note down this problem and try to calculate how to calculate the pH of hydroxide ion solution. Note down this problem and try at home. And in next video we will discuss calculations of pH and H plus concentration for weak acids. Weak acid, because formula will be different there. Thank you very much, student, for your patient listening.